All right. Hey, Advanced Algebra team. Welcome to Chapter 3. Today we are going to introduce solving systems of linear equations by graphing. Our EQ for today is what is a system of equations and how can I solve them by graphing? For the warm-up, we need to see if each point is a solution to the equation. We've done this previously, so a reminder that in order for a point to be a solution, when you plug in the x value, it has to equal the y value. So for this first one, if I plug in -2 for x, in order for it to be a solution, it has to come out to equal -4. So let's see if that does. So if I do 2 minus 3 times -2, -3 times -2 is a +6. 2 plus 6 does not equal -4, that equals 8. So this then is not a solution. Let's look at the next warm-up example. We'll move down below. So I have 0 as my x value. 2 minus 3 times 0 has to equal a +2 for this to be a solution. 3 times 0 is 0. 2 minus 0 is equal to 2. So this indeed is a solution. Pause the video real quick, solve to see if 8, -20 and 3, -7 is a solution or not a solution, and then come back, replay it, and check your answers. All right, hopefully you paused it. Let's fill this in again. So I have 2 minus 3 times 8. That has to equal -20 for it to be a solution. 3 times 8 is -24. And 2 minus 24 is equal to -22. So this is not a solution. And then the last one, 2 minus 3 times 3 has to equal -7 for this to be a solution. 2 minus a +9 is equal to -7. So this indeed is a solution. And we're reviewing this information because this is how we are going to start to see if something is a systems of equations. All right, so what are systems of equations? As we will mention in our lesson, a system of equations is a set of 2 or more equations with the same variables. Okay, so 2 or more equations with the same variables. And in order to be a solution to a system, an ordered pair must make both equations true. So an ordered pair must make both equations true. Today with graphing, we are going to solve to find the ordered pair that makes the systems of equations true. All right, let's see then if each of these points is a solution to our system. So as we said, a system of solutions is 2 or more equations with the same variables. Here we have 2 equations and they each have an x and they each have a y, which means that this is a systems of equations. And our question is asking us to determine if the ordered pair is a solution. Just like we did in the warm-up, you're going to take the x value, plug it into the equation, and if it is a solution, it has to equal the y value. But it has to equal the y value for both the top and the bottom of the equation. So let's look at the first one. If I have 2 times 1 plus 1, 2 times 1 is 2 plus 1 is equal to 3. So we know that this first one then works with the ordered pair, but in order for it to be a solution, it has to work for both equations. Let's look at the second one. 3 times 1 plus 3. So this is a little bit different. The y is plugged in to where we're solving, and this has to equal 6. 3 times 1 is 3. 3 plus 3 is indeed equal to 6. So both of these work with the point 1 comma 3. So this is a solution. How about the next one? We have a system of equations and the point 3 comma negative 3. Let's plug it into this top one. 15 minus 3 times a negative 3 has to equal 2 times a positive 3. So again, our y value we plugged in, and our x value we plugged in, and we have to see if this statement is true. Negative 3 times negative 3 is equal to a positive 9. So 15 plus 9 is equal to 2 times 3 is 6. Well, we know 15 plus 9 does not equal 6. So this does not work. And in order for an ordered pair to be a solution, it has to work for both. So we don't even have to check the second equation. This is not a solution. Now, when we solve systems of equations by graphing, we have to graph both of the equations and see where they cross or intersect. And that intersection is our solution to the systems of equations. As we talked about in chapter 3, in order to graph, or in chapter 2, excuse me, in order to graph, we want the equations to be in y equals mx plus b, which allows us to have b as the y-intercept. And m as the slope. So we can see that the second one is clearly in y equals mx plus b. The first one's a little bit tricky because the y is over here. So if we want to rewrite that as y equals negative 3x minus 7, so you can see it, it's in y equals mx plus b, it's just flipped backwards. If I graph this first one, I'm going to cross this out as I know I rewrote it. My y-intercept is negative 7. I start at 0, 0, and I go down 1, 2, 3, 4, 5, 6, 7. And I have a slope of negative 3 over 1, which is rise over 1. So I'm going to go down 1, 2, 3 over 1. Now, when we graph these, we also might have to go to the opposite way. So I might have to go up 1, 2, 3, and to the left 1 to make it negative. So up 1, 2, 3, left 1, 1, 2, 3, left 1, and follow that line. So that is our y equals negative 3x minus 7. Now let's graph y equals 3x minus 1. So I know I'm starting at negative 1, and I'm going up 3 and over 3, 1, 2, 3 over 1. 1, 2, 3 over 1. Just after 2 points, you can see that my line isn't going to connect up here. But if I go the opposite way, so down 3, 1, 2, 3, left 1, 1, 2, 3, left 1, these lines overcross at this dot that I just turned red. So in order to figure out what point that is, I'm going to start at my origin of 0, 0. In order to get there, I go left 1. So I know my x value is negative 1, and I go down 1, 2, 3, 4, negative 4. So the coordinate point that is the solution to the systems of equations is negative 1, comma, negative 4, because that is where the two graphs intersect. All right, let's look at this next example. So you can see right away that these are not in y equals mx plus b. Which means that in order to graph them, we have to rearrange both to be in y equals mx plus b. So let's look at this first one. 2x minus 5y equals 15. I have to get the y by itself, so I'm going to subtract 2x from both sides. Negative 5y is equal to, I like to put the negative 2 out front, whatever number has that x, plus 15. And then in order to get the y by itself, I have to divide by negative 5. And remember, when you divide, you have to divide every term by that number. So it ends up being y is equal to 2 over 5. A negative divided by a negative is a positive. X 15 divided by a negative 5 is a negative 3. This now is in y equals mx plus b, which allows us to graph it. However, before we can graph the second equation, we also have to rearrange it to equal y equals mx plus b. I'm going to shrink that. So then we have 3x plus 5y is equal to 10. We are following the same steps that we did in that first equation. So we have to minus 3x from both sides. If this is something you're still struggling with, please make sure you ask us during class on how to rearrange these to be in y equals mx plus b form. Then I divide everything by 5. Again, every term needs to be divided by 5. And y is equal to negative 3 over 5 does not equal a whole number. So I leave it as negative 3 over 5x. 10 divided by 5 is 2, so plus 2. And this then is my second equation that I am going to graph. So, all right, so if I want to graph this first one, my y-intercept is negative 3, so I'm going to start at 1, 2, 3. And I'm going to go up 2 over 5, 1, 2, 1, 2, 3, 4, 5. Up to 1, 2, 3, 4, 5. And then you always want to go the opposite way a couple points. 1, 2, 3, 4, 5. Down to 1, 2, 3, 4, 5. All right. Now, in order to find our solution, we're going to graph this second equation, which starts at a positive 2, 1, 2. I'm going to go down 3, 1, 2, 3, and over 5, 1, 2, 3, 4, 5. And right away, we find that one point where they intersect. So I'm going to make that dot red. And in order to find that point, I'm going to start at the origin of 0, 0, go to the right, 1, 2, 3, 4, 5. I know my x is 5. And I go down 1, which is negative 1. So my ordered pair that is a solution to the systems of equations is 5, negative 1. Okay, so the biggest points, if you want to write the steps, are to make sure equations are in y equals mx plus b. And then you graph each equation and see where they cross. Ran out of space as always, like Miss Michael does. They cross. All right, so we can do this graphing by hand, right? By rearranging things equals y equals mx plus b, finding where the two graphs intersect. There can also be done by solving with the calculator. This is something we're going to go through in class. So you can leave this note blank, and then when we come back to class to go through the notes, we will show you on the screen how you can use a calculator to solve systems by graphing. All right, let's talk about when we have a different number of solutions. So in every example that we have gone through, we have seen either one solution or no solutions. So the first one is one solution. You will see this about 90% of the time in the examples that we go through. When there is one solution, it simply means that the graphs have different slopes and they cross at one point. So if I draw two lines, these are just two very random lines. Obviously, my purple line has a negative slope, my blue line has a positive slope, and the point right here would be the solution to these two systems of equations. When there are no solutions, this means that the graph is never going to cross. And in order for a graph to never cross, they have to be parallel lines. And what we talked about in chapter 2, in order for lines to be parallel, they have to have the same slope. However, for it to be no solutions, they have to have the same slope, but different y-intercepts, meaning that they cross the y-axis at different points. And then finally, infinite number of solutions. In order for something to be an infinite number of solutions, it has to cross every single point. If I draw a line here, in order for another line to cross every single point, it's got to be the same line. I'm going to try to show you that there's two lines there. So for systems of equations to have infinite number of solutions, it's going to be the same slope and the same y-intercept. Again, 90% of the time in our systems of equations, you will only have one solution. Our summary, answering our question, what is a system of equations? A system of equations is two or more equations that have the same variables. And the second part is how can I solve them by graphing? You're actually going to go up and copy and paste these steps that I just wrote. Copy and paste. So you have to make sure that the equations are in y equals mx plus b. And you graph each line by plotting that y-intercept, then using the slope and seeing where the two lines cross. As you go through these notes, please make sure you're putting stars or question marks on things you do not understand so you can ask questions during class. Thanks, team.